Okay. I think I'm ready. Go here. And I think we're good. Alright, guys. Let's get started. See if we can figure out what I have done wrong in my life. Just kidding. At least in this one area. Let's open up our binary search tree. Let our LSP load. And then let's see where we were at. We had a failure in our test. That's where we left off last time. Oh yeah, let me start a recording here. Been trying to remember to do that. Cool. Done. Alright, so we left off last time with a test failure on our binary search tree. And that was the case where we deleted the 2000. Okay, so when we delete 1000, we get what we expect, which is 900 and 800 go up. So that test works. But what happens when we delete... Oh yeah, we actually got a panic. Oh right, it was just here. So it's almost like it can't even see that 2000 is in our tree somehow. Very weird. Okay, so let's figure that out. So we have a swap node. Okay, so delete calls delete from. And let's see where we wanna, what we wanna put here. Yeah, let's go ahead and log out as we recur down this way and see what happens. Where is it looking for it and why isn't it working? Give me 1 second. Okay. All right, let's see what we're gonna get as we go down. So we're gonna get debug and self.value. That should be fine. And that should tell us what we want to know. Yeah, I think that'll be okay. Okay. What? Okay, so it goes 10, and then it goes to 2000. Okay, there's something wrong. Okay, wait a second here. Oh, we deleted 15. That's what's wrong. Okay, that's why this tree is wrong. I forgot that I deleted 15. Okay, so let's go ahead and delete 15 so we can see the current state of our tree. Okay. And then after we deleted 15, we delete 1000. Yeah, that's weird. Oh yeah, I didn't even think about that. It should never get to a place where self.value is the actual value that we're trying to delete. I mean, our code looks right there. Huh. Why would that be the case? And why would it go right from 10 to 2000? I don't think we deleted 17, did we? We deleted 15. Okay, let's look at our prints before that. Make sure that they look okay. Let's see. We want our debug print at 5. 5 at 199. Yeah. Okay, so this is the one. 5 above 199. So we have 105414. That is correct. And on the right we have 17 and 2000. Yes. Okay. So we have 17 and 2000. 2000's on the right. Then we insert 1900 and 800. So let's do a debug print here before. And we should also see the debug print at 204. 1054.149, 17, 2000, 900, 800. Oh no, we had that. So we know what that looks like there. This is all correct. It's all on the left-hand side of 2000. Okay, so I don't need this one. Okay. Oh, hey, Purplish. Sorry. I was not looking at chat. How's it going today? Hope you're well. Give me 1 second. What was I looking for? I don't remember anymore. Yeah. Okay. All good. Okay. So, somehow, let's get back to this. Somehow we're printing out 10 and then printing out 2000. Which 10 is our root node. Which makes sense. But why are we not ever printing out 17? Oh, actually, that probably makes sense with our logic. Let's look at our logic. Sorry for all the scrolling. Okay. Okay. Just random things I forgot to check on before streaming. You know, classic. Okay, so the first time we have our root node, or root node is self, we are printing out self.value. It's saying if value is less than self.value, then we're going to go here. L's value is greater than self.value. So we know that we're going to match on the right side because we're at 2000. And then we're going to say if Let's see. Did I already mess up something? No. This is just matching on right. And so this is our right node. So this n should actually be 17. And that's the part that I was being silly about. So let's just run our test and see that I'm right. Okay. That's confusing. Did I not save? I did save. Huh. Oh no, this is if value equals n dot value there. Okay. Otherwise, if value is less than n dot value. Oh, this is the mistake. I think. Just give me a second. Let me think about this. Let's think, because it's the same logic for both. And so there's probably a similar error where I'm skipping over things. If value is less than n dot value, then we want to recur down node our right dot left. That makes sense. And then we'd have delete from value. Okay, that's where my debug print is wrong. My debug print is wrong because it's not doing it on every case. So it doesn't ever print out 17, and it shouldn't. Okay, so we skip over 17. And we recur down the right. In this case, we should find that value is not less than n dot value. I think what we should be able to do is something like this and say else debug. I guess we could just debug print the whole self.right. Let me think. No, that would be messy because it has all the children. Yeah, that's fine. Debug self.right dot as ref dot and then n dot value. Okay. So let's just do this. And expected option unknown, but found T. Oh, right, because this is supposed to give me an option. Let's just do a map. Can you do a map? Right, a map is safe, right? Because if there's not a value inside the option, it just doesn't do anything. I think that's right. So, nope. What's wrong now? Oh, okay, that's fine. I don't need to move out. I'm fine with a reference. Okay. Here we go. Yeah, all right. So 10 is our value on top, and then our right is 17. We go down and we say self.value equals 2000. Okay, so we have 2000, but as far as I can see, oh, I am skipping in the algorithm. Classic. Okay. Yeah, I just did this wrong. That's fine. Okay. So let's just think about this. We started our root node. We check if our value is less than or greater than, and then we choose whether we want to go down the right side or the left side. We have to look at it from the parent reference. Since we're looking at it from the parent reference, then we are going to go ahead and say yeah, debugging working as expected. Yeah. I'm really bad at looking at chat today. I don't know why. I guess because I'm trying to think through this. Yeah, I finally found the error. At least I like literally just figured out what I'm doing wrong is I'm skipping over a value completely. So I'm like I'm making 2 jumps when I should be making just 1 jump. But I have to think of how I want to do this in a way that makes sense without having to recheck everything. Oh yeah, I think that's actually where I have it wrong. Maybe all I literally want to do is say if, okay, so I'm at my root node. I say if value is less than self.value, yeah, I just made it more complicated than I needed to. Then let's check if our left is that value. If the left isn't that value, then we're going to recur down the left, but we don't need to do an extra check here. So instead of this whole thing where I'm actually going down into the left.left and left.right, essentially, I should just be saying n.delete from value. And that's all I need to do. So all I have to do then is my base case here. I say base case, but it's not from a recursive example. Actually, my recursive case is if there is a sum in. We already know there is, but I'm just going to leave it there for expressiveness. Then we just want to say n.delete from, excuse me, n.delete from value. Yeah. Yeah, that's right. Okay. I'm like quite sure this is correct. Let's see. Do I have a, I'm pretty sure I have, ooh, I might not actually have a commit. So I'm going to delete this and we'll commit this and then we'll make our changes. DST jumping bug. All right. And then we can paste that and go here. And this should compile. Yep, we checked all of our cases. And then it's going to be the same thing down here. Paste. And there. That makes more sense. Okay, cool. So I just made it more complicated originally than I needed to. Okay, awesome. So everything prints, right? Let's just go through all of our cases. You have that t-shirt. Like the making everything way more complicated than is necessary t-shirt. Yeah. I think it comes with the job, right? It's in the job description. Okay. So I'm going to go up here and we're going to walk through this. Where are we? Maybe we should start with a clean tree and just walk through our test examples. I think that would be cool. Make sure that our binary tree is working like we believe it should be. I think that's a great idea. Okay, so got Emacs where I can see it. And we'll just start with a clean binary tree. 7, 15, 9, 4, 17, 34, 58, 2000. Okay. And then in our test, we just do some searching after that point. Obviously, those are all checked to make sure that we actually inserted the elements, and we're happy with that. And then in our test, we insert 1, 5, and 6. Okay. That looks good. All right, at this point, we delete 7, and that is here, right? Yeah, okay. So we delete 7, and we insert a 4, and we delete a 6. Walking through these like this, it doesn't make a hell of a lot of sense, but that's also because these were like, as I was coding it out, testing out different examples. Okay, so after we delete 6, we have our first tree printed. Okay, so let's check and see if we have the right structure. This is when we have a 10, 5, 4, 1, 4, 9. Okay, and that's what we have. 10, 5, 4, 1, 4, 9. So that works. Sweet. And then on our right, 15, 17, 34, 58, and 2000 should be untouched. We haven't even touched our right yet. Okay. So then, what do we go to? Then we delete 3458. Okay, when we delete 3458, we should just see a change on our right-hand side where 17's right changed to 2000. So let's see if that happened. And now we just have a 15, 17, 2000. You got it, Purplish. You got first. Teeny's falling behind, you know. I don't know where he is today. You know, he's school, all that stuff. It's awesome. Usually I see it in chat too. I'm a little confused why that didn't show up in chat. Maybe I'm being crazy. No? I don't know. Whatever. I thought it showed up in my chat box. Whatever. Okay. It's right. Okay, so we have 15, 17, 2000 after we delete 3458. And then we delete 15, and that should just bring it up where we have just 17 and 2000 on the right hand side, and that is what we should see. Haven't touched our left. Yep, 17, 2000. Beautiful. And then the next part is where we insert a bunch of elements, 1900 and 800 onto our right side. to get this big left branch going. And this is what helped me find this bug, so yay. Okay, and the first thing we do is delete 1000. Okay, that's good. And then we have 2000, 900, 800, which is what we have on the left hand side. Yep. Okay, and then we delete 2000, which should leave us with 17, 900, 800. And so that looks correct to me. Let's look at it on here to make sure that we didn't screw up anything. Right and left. Perfect. And that was it. Nice. So that bug is taken care of. I'm reasonably sure that delete works at this point. I'm trying to remember. I imagine that I tested deleting a node that has no children, but we might as well do that real quick to make sure. Hey, Teeny, what's up? We were just talking about you. Because Purplish actually redeemed first. How's it going? Found the bug in my delete, and it was me just making things more complicated. I don't think you were here on Friday, but yeah, you know, classic me. Yeah, these match statements are a lot simpler than they were. Before I was like reaching into, like I'm already reaching into, you know, the left and right branch of self in this case. And then before I was reaching further down into them, and without thinking about it, what I was actually doing is skipping over nodes completely. Because instead of recursing over like self.right, I was like skipping right down to recursing over self.left or self.right.left or self.right.right, you know? So there was never an equality check, of course, like on the nodes that I was skipping over. So it made it pretty obvious once I deleted enough elements in my tests. So anyway, it's a little bit simpler, a little bit nicer. It is actually, yeah, it's, I don't know. I think there's like a nicer thing I could do here, but I don't know. I mean, this is what I said originally when I started this function, but like I do like the expressiveness of just like, if value is less than self.value, we know we're going left, and if it's going right, otherwise we know we're going right. And then we just have these matches, and I think combining those two will just make it obfuscated. So yeah, it seems like delete's working well, except for our root node. We haven't implemented a delete for our root node yet. But I think the good thing about that is I should be able to just do this. Since nothing is... Okay, so since nothing is actually referencing our root node, we don't have to worry about updating anything besides... Oh, that's what it is, obviously. It's going to be if... Okay, let's just code it out. How about that? What if we just like actually wrote code? How would we feel about that? Okay. So this is where we can write it. If let some node equals self.root.asMute. Yeah, I think let's change this into a match statement, and it will be a little bit nicer that way. Why did I say match some node? Oh my gosh, I'm being dumb. There we go. And we'll just do this. And let's see. Yeah, so our base case is if there's none. So let's just do this here. And then if we have sum and the value equals the value of our root, then we're going to say if n.swap node is none, then oh, that's true. Oh, that's kind of weird. Hold on a second. n.swap node. Will this work? Yeah, I think it will work actually, because the swap node stuff. Let's see. Stop doing things, Michael. Okay. Let's just update. Let's make this compile first before we look at possible bugs. Self.root equals none. Okay. And then return some value. So this will actually be the end of this. Okay. And then right. Whoops, I didn't mean to do that. I was trying to do two things at once. So this is going to be n, and there we go. Otherwise, if there is a root node, we're just going to recur down it. Okay, that should be fine. And then we go here, and then we might have other problems, such as not having enough closing brackets. That's a problem. Okay. Well, I mean, we can just try it and see what happens, right? See if we get what we want. Let's just make sure that it's building and the previous tests work. Seems like it. Let's just check our structure of our very last thing. We have 10, 5, 4, 1, 4, 9, and 17, 900, 800. Perfect. Oh yeah, teeny. Funny story. It turns out, let's see if I can get this part to work. Guessing the scene thing might actually not be there anymore. like it might not be a problem anymore. It's very silly. But I was so frustrated the other day because I spent like 20 minutes on web browser when I was on Emacs, and I'm just like, I've got to figure something out. And then I was just clicking around OBS and I see automatic scene switcher, and I'm just like, oh my god. Like right away I was like, I am like 99%. Oh, you couldn't hear me. Oh no. Oh no, that's right. I don't have my mic imported on that scene. Oh, that's hilarious. Skill issue. Alright, I imported my mic. Alright. Well, you guys probably got the point. The point is, there's an automatic scene switcher. Yeah. It just does all the work for me. Pretty ridiculous. You just heard the music louder. Oh no, I see what's happening. Hold on. There we go. That should be it. Okay. No. Yeah. I was really fucking that up. Are we good now? I think I fixed it all. Well. Yeah. Okay. Classic. OBS skill issue. Real hard. So I explained it twice, and I'm just not going to explain it again because I'll probably just fuck something else up. But I think you guys got the point. Automatic scene switcher for the win. Pretty funny. Okay. So, you know, we go back and forth. I don't have to worry about my Mac keys stopping working. We can just do this all day. Pretty excited. Pretty excited about it. Okay. So our ending tree looks good, which means we didn't cause any regressions. So let's go ahead and try to delete our root node. What is it, 10? Now we might need secrets. What would the secrets command do? I'm not following for some reason. All right. So let's talk about what should happen. Oh, for leaked secrets. Yeah. No, actually, we probably do need that. Yeah, no doubt. Yeah, when it changes automatically, I know. I do try, I try really hard to never open anything that has secrets on this desktop. So like as in, you know, like Mac desktop, right? Like this workspace. I only open sensitive things on a separate desktop that never is shared on OBS. So yeah, we'll see what happens. I've already leaked a couple things and I haven't really bothered to even edit them, and they're literally just on YouTube. It's not like sensitive stuff, it's just more like personal information. Oh well. Oh well. Okay. Oh yeah, we were going to talk about what should happen when we delete the root node. So what should happen when we delete 10 is it gets replaced with 9. Pretty simple. Let's see if that's what happened. 9, 5, 4, 1, 4. And there should be no 9. Beautiful. And 17, 900, 800. Sick. It worked. The algorithm worked. It's not beautiful. We did it all within impl blocks, which is probably not something I'd recommend doing and not something I'd do on a whiteboard by any means. I would just do it in like a normal recursive function instead of trying to like fit it into these impl blocks and make it super, super annoying. We probably could have written like, I don't know, half the code maybe? Half the lines of code if we just did it in impl blocks. I mean, I'm sorry, in normal recursive functions rather than as methods on these types, but that's okay. I wanted to see if I could do it this way. Who wants to do things the easy way? You know, I mean, binary search trees in Rust are just so easy naturally. Why would you want to do them the easiest way possible, right? You gotta add some challenge in there. I learned it was a pain in the ass. That's what I learned. Now, I mean, I did learn that, but also, I think it helped me model. Oh my god. Oh my god. Hey Dylan. Oh yeah. Redeem that, no apologies. Hey guys, thanks for the raid, Dylan. Yeah, you know, just your classic boomer trying to play with this new fangled technology. Thanks for the follow, usually Chips, and a username that I cannot say, the CAD mini characters Canab. Thank you so much for the follow. And Cherry Heart, thanks for the follow. Sadly this is not OCaml. I'm sorry guys. I mean, right now you just see my browser, so it's really not OCaml. Sweet. Thanks, Dylan. I appreciate the raid. Have a good one. Well typed witch. Hey, thanks for the follow. We are working in Rust. We've been doing data structures. We've done quite a bit. It's been pretty fun. I like OCaml for the most part. It's a little too hype right now, you know. And I just really all I mean by that is, you know, I'm too much of a hipster in the sense that like, oh no, OCaml's getting too popular for me. Let me go to Haskell instead, right? Nobody likes Haskell, right? Is it still something no one likes? Okay, I'll use that. No, I mean I'm kind of kidding. But you know, OCaml, I have like a functional background, and so OCaml is definitely something that I appreciate. I haven't got into too much. I did write a fair amount of Haskell about 5 years ago. Haven't really touched much of it since. I'm MetaMe. You know me possibly from my trolling of Dylan in chat. And for some reason he made me a mod after trolling him for like the first week of him streaming, and then he made me a mod. I don't know why he did that. Will this help you prepare for LC? What is that? Oh, leak code? Yeah, for sure. For sure. OCaml, Common Lisp, and Rust are probably the language that I'm most happy to learn about. Yeah, totally. I feel that. Thanks for throwing some Lisp in there. You're gonna love the next thing I say then, Cherry Heart. You see, no, it's not Common Lisp. It's the only Lisp that you can really get paid to write at this point. And that is, as a non-academic, that is. But yeah, I write Clojure for my day job. Have for the last 5 years. I use Emacs, sorry, you know. Oh, you know, you redeemed no apologies. I just apologized. I'm not really sorry, so it's a fake apology. So I use Emacs. I use Evil Mode, which is Vim motions in Emacs. For those that don't know, it's really well done. As far as not using Vim, but but using Vim motions, evil mode is about as good as you can get. But that's because, you know, Emacs is an OS, as we all know, right? So that's how that goes. As long as you use Vim motions, it's okay. Yeah, absolutely. Yeah, we do the full, you know, look at this. Look at those J's. You see that? Yeah, we can do that. No problem. We can it auto translates everything, so you'll see if people know Emacs at all. When I just put in the number 12, and usually to put in a numeric argument to a Emacs command, you have to press Control U. This is why people who use Emacs don't have pinkies. And then you would do the, if you wanted to jump 10 lines down, for instance, you'd press Control N in Emacs. But, you know, here it just translates it. I do CU, I do 12J. It says I did CU 12J. J is just remapped. It's basically Control N remapped. So pretty funny, pretty funny. Thanks for the follow, Smiling Big. I really appreciate it. Yeah, so I'll give you guys a little tour. You guys came at a good time because I absolutely first try and only who knows how many hours of streaming. I finished my binary search tree in Rust, so pretty cool. Right now it's just got insert, delete, and git, but you know, or search. But I mean, what else do you need? But yeah, let's see. We started this a few weeks ago. We started with an array list migration from Emacs to NeoVim stream. I have actually been thinking about it. I will probably try out NeoVim at some point, and I mean, might as well do it on stream, right? Why not? That's what we do here. My favorite is I don't remember to press Control, which would be nice because it would do nothing for me. But I do often press P instead of K. And that just, of course, means I just end up pasting shit all over the place. So, good times. Love it. Yeah, it's actually true. That's actually a really good point. Like, I've been doing things that like I've wanted to do on stream, you know, like the data structure stuff in Rust, without pandering to viewers, but like actually Emacs to NeoVim would be a big thing. That's hilarious. Yeah, so we started with an array list, which in Rust the array list is avec. There we go. Look at that. And that was fun. Then we moved on to stack, and here we used unsafe Rust. Yeah, sweet. Yeah, this is loosely based on Prime's course. Like I started with, yeah, thanks a lot, Aaron Bragas. I appreciate you hanging out. If you want some more Rust data structures, send me a follow before you go, if you're still here. Maybe you already follow me, I don't know. I'm getting to the point where I'm having a hard time keeping track of who follows me, which should be obvious, but, you know. Yeah, thanks for the follow, I really appreciate it. Have a good day. Or night, depending on where you are in the world. Yeah, so we did unsafe. This was my first time using unsafe Rust, which was cool. Manual memory allocation, doing growing your allocation underneath. I just used, for the stack, I didn't use a linked list. You could implement a stack with a linked list. That's what Prime does, I believe, in his course. I can't remember. It's been a few months since I looked at it. But here we're using an array. Like, essentially this is an array list at the end of the day. It's just functioning a little bit differently. But very simplified stack. Pop and push at one edge. And that's what we have. So that's pretty cool. And then we went and did linked lists. Linked lists in Rust were a lot of fun because of the borrow checker. You have to think about a lot more than you do other places, but it was not as bad as I thought it was going to be. So we did some options, some boxes, which is a type of smart pointer in Rust, in order to make our linked list work. And that also helps us with our lifetimes and other things like that that you'd usually have to specify if you wanted to do it a different way, like with actual normal pointers, you could say. And then we did a doubly linked list, which for the borrow checker is even harder because you have more than one reference to everything. And that's where we used an RC ref cell for reference counting pointers. Ref cell gives you mutability under a reference counting pointer. And that was our doubly linked list. So once we had a doubly linked list, what could we do with it? We could make a queue. And that's because first in, first out, to do efficiently, you want that constant time at both sides, right? You want to be able to push onto the head and take off of the tail without any issue. And so a doubly linked list is a fairly reasonable data structure for something like that, depending on your use case. And that's that. In Rust, like I said before, the vec type is an array list. The linked list type in Rust is a doubly linked list. And then after our queue, we went and did a ring buffer. Ring buffer was a lot of fun. And this again is using unsafe Rust. We are allocating our own memory, manipulating our own memory directly. And this gives us that ability. We did a fixed size ring buffer with the ability to, it gives you constant time at both ends for both adding and removing. So that part's pretty cool. We did quite a bit more on our ring buffer than we did for some of our other data structures, and gave it an index trait, index mute trait, iterator traits, double-ended iterator trait, etc. And one of the cool things about traits in Rust is that, for instance, implementing an index trait on a custom data structure, like this is just my ring buffer that I implemented. And then I have this nice like index access here. So index trait gives me this kind of JavaScripty C style array access. And then index mute right here, that actually gives me the ability to mutate the value at that index. So that's pretty cool too. And then of course an iterator, you probably know what that basically is. So we implemented our iterator for a ring buffer as well. So that was pretty cool. And after we did ring buffer, we started our binary search tree, which as far as a basic implementation, I have another Emacs frame open, so it opened it over there. As far as a basic implementation is done. We just finished that. For those that don't know, this is a basic binary search tree. Essentially, you start with your root element. Everything on your left branch is going to be less than the value in your root element, and everything on the right branch is going to be greater than, and then if it's equal to, I just put it on the right. Different implementations treat equals a little differently. So MXV term even. Yeah, that's really good, Silicon Milk. That is absolutely true, which is where we get into Emacs as an operating system, right? That's a great like meme joke. Like I should do that. I should do that at the beginning of that stream and just be like, okay, we did it. We're done. We finished. That's funny. Yeah, so this is our binary search tree. And binary search tree is great because searching's efficient. So it's not as cheap as those other data structures we talked about to add things to either edge, you could say. but like that's not constant time. But almost all the operations we really care about are going to be logarithmic time, where, for instance, if you had an array, right, and you wanted to add, say, an array list, you want to add something into the middle. It's not the most efficient thing. Worst case scenario, right, that would be linear time, O of n. Here we can have that in logarithmic time. So that's a binary search tree. So that is what we just finished, which is pretty cool. So let's go ahead and commit that. For those of you that want to follow along, there is a playlist on YouTube. All the VODs are also here on Twitch. Yeah, man, for sure. Clojure, like using Clojure professionally for 5 years, like it's had its ups and downs. What I've finally come to is that I really love the language, even though I hate the JVM. And that's like, before I was on Clojure, my main backend language was Java. And so like I have a fair amount of experience with the JVM, and there are people that probably make it work really nicely, but that is not the JVM is not the most efficient environment. I'll just put it that way. So there's that. I do love the strong types, of course, in like a really good type system, like a Henley-Milner type system, which of course OCaml has, Rust has, Haskell has. That's my jam. I love those kinds of things, but types aside, like just getting shit done, like Clojure is so nice. It is a very quick, very nice language. I am considering, I've been talking to CM Griffing, if people know who that is. But I've been talking to him about maybe doing kind of like Dylan's doing for OCaml SDK for CM Griffing, doing a Clojure SDK. I haven't really wanted to stream Clojure because it's what I do for my job, and I've also been trying to learn Rust, and Rust is my first systems lang, just so people know. I don't have a CS degree. I have an unfinished master's in philosophy. Yay. Yeah, that's kind of that. Yeah, there's a lot of cool projects to get Clojure hosted on different environments, for sure. There's a lot of good. There's Clojural, which is a Clojure on the Beam, the Erlang VM. And I have, and then of course for a while they tried to do Clojure on .NET. Maybe that project's still going. And then I have heard about the C++ one, which is very cool. There's a lot of great work that people have done. I can't remember. There's a guy on Twitch that actually works on Babashka, which is a bash interpreter for Clojure, and a lot of the work that they have done to make non-Java dependent, non-JVM dependent work for Clojure is really remarkable work. So if they can get like buy-in, that's going to be pretty awesome for sure. Ashav Dev, I don't think I thanked you for the follow, but thank you. I appreciate it. Yeah, Babashka is very nice. I don't know if I have like a simple example on my system. Let's see. I'm gonna jump over to my work terminal, which I use a different terminal so I don't leak things, teeny. But I might have a nice Babashka example that doesn't have actual any work information in it. Do I not? I might not. But yeah. Suffice to say that Babashka is excellent. Oh well. Sergio Quijano or something close to that. Thank you so much for the follow. And if you want to tell me how to pronounce that, that's cool too. Yeah. Yeah, exactly. It is very helpful. Okay, so we finished our binary search tree basic implementation. Let's just go over how we did it, like as just a review, and then we can talk about if there's anything else I want to add to it. Right now it's pretty lightweight. Yeah, awesome. Thanks, Ash. Ash Avdev. So our basic... No, it's fine. Yeah, well, I have a lot of Spanish, unfortunately, but the J in Spanish has always been a little bit... For whatever reason, it throws me off. Even though I've done a fair amount of Spanish in my life. Very rusty at this point. Very rusty. I'm old now, and it was mostly when I was in college. So that's 20 years ago at this point. It's hard when you get old and you don't use things, you know. So our basic type here, I think this syntax shouldn't be too confusing to most people. It even looks a little TypeScripty. That's just sad to say, but you know, I don't want to. You know what? I should take that back. We don't want to talk that sort of language here. We don't want to use that sort of language here. Okay. So we have a basic binary search tree, and then that just has a root, and that's J is one of the ones that's harder, and that's with like years of Spanish education. Now it's probably just that I'm like forgetting, and I also feel like depending on the dialect and where you're from, I feel like Spanish speakers actually pronounce the J differently a lot more than other letters. I don't know if that's true or that's just like my perspective, but that's kind of how I feel about it. No apologies. Again, I need to put a time limit on that. Once a week. Yeah, that's really true. Cool. I'm glad it's not just me. Like growing up, I grew up in Southern California. I would say the most common, you know, it's not an official dialect, but you know, like Mexican Spanish is probably what I was most used to, and that's mostly what I learned in school. Oh, right. Yeah, and then, you know, of course, Castilian is like its own, like that's what we call it, right? Is just Castilian. Oh, that's Spain Spanish, you know, and but there's so much more than that, of course, you know, so much more. And then, of course, if you're Baja Blast, you say Bahia, like, wait, Baja, right? Like Baja, California. Like pronouncing it as, for me, saying the H in hard without the Spanish J is impossible. Yeah. Yeah. Baja Blast. I mean, we say it's Baja, California, right? Like I guess you'd call it a Mexican province just south of California. I don't know. Spanish is cool though. It's great language. I enjoy it. All right, and then our node struct is here. It simply holds a value, which is a generic over T, and then it has a left and right branch. Man, Portuguese is like I can figure out some of the other languages, but for whatever reason, Portuguese is really, really hard. I do not get it at all. Like, I took some French in college. I took a lot of Spanish I also took Spanish in high school, secondary school. And then Italian, it's like close enough that I can figure it out. It's pretty, like, you know, I can mostly figure it out. But yeah, like Portuguese, I just feel like is so much harder than those other ones for some reason. And it could just be like I haven't spent time to figure it out, like just understand some basics. But yeah, I bet. But like when I listen to somebody speak, you know, Spanish or Italian, it's like I can mostly understand a fair amount of it. And like when I listen to somebody speak Portuguese, no idea. If I see it written out, like I understand like a fair amount of written Portuguese, but spoken, I'm just like completely lost. Okay. You just followed me because I was having a hard time with the J's, didn't you? Now, RJUU, thanks for the follow. I appreciate it. Shovel in Spanish is like our normal S sound. I don't know if I'm following. Shovel. Are you just saying because there's not like a sh sound in Spanish? Yeah. Oh, your S sound is the same as the same as the SH sound. Interesting. Initial H are more airy in English, yeah, for sure. In Spanish are strong. Zh, yeah. Languages are cool, no doubt. Spoken languages, programming languages. All right, so we have, yeah, I'm getting distracted by languages and then like just trying to go over these types. Pretty funny. Which is no problem. Please continue. Okay, so we have our binary search tree. We have our node that has the root of the node. We're using an option box to express optionality. Box because it makes our pointers and our lifetimes simpler. Like closure. Closure. Like Prime says it. Closure. Closure. Yeah, right. Okay. Uh-huh. No, I seem like I was gonna say like, do I seem like completely crazy right now? I mean, I am autistic, so there's that. But anyway, okay. So then we jump down to our binary search tree, impl. Yeah, smooth scrolling just to trigger everyone, and we have our constructor. That one's pretty easy. We just construct our struct and set our root to none. Insert is actually super simple. All we're gonna do is create our actual node struct. If there's nothing in root, we add that node to root. Otherwise, we insert node as a child in root. Insert child here goes into our node implementation, and it's just a basic recursive find out where this node goes, whether it's in left or right, basically. So that's insert child and insert. Search is also fairly simple. We just do a recursive search down through each branch and check our base case is when the value actually equals the value. And if the value doesn't exist, then it returns false. Delete is the hardest part, and it took me a while both to remember the algorithm, and then I tried 3 or 4 different ways of doing it, and finally ended up with something that is not the prettiest, but also isn't the worst. I've done a lot worse things. Are you asking me, Cherryheart, what my main programming language is for work? It's Clojure. Yeah, I write like 99% Clojure for my day job. It's not so bad. And we match on our route. Yeah, it's pretty awesome. I mean, I purposely picked the company for the language. I'll say that. I was pretty deep into functional programming before I got that job. And hey, thanks for the follow, Silicon Milk. And so I was looking for Haskell jobs. Meme. I was considering Scala jobs, which I probably wouldn't do at this point. I don't actually like Scala that much. It's just too... I mean, I haven't used it a lot, and so I'm not going to say this is true, but I feel like Scala is way more complicated than it needs to be. Like, I think Scala is actually more complicated in some ways. Like once you learn the languages, which I like, the learning curve is a lot higher for Haskell than I would say it is for Scala, but I think Haskell is a simpler language than Scala at the end of the day, and you're still on the JVM with Scala. Yeah, for sure. Yeah, I mean, it's hard to know like what's right in the market, but I think if you learn a lot of functional programming concepts and then you just try to apply them, you can try to apply them at work depending on your work situation, just to get practice with the idea of how to solve those problems. More likely you can apply them in your free time. Right? But yeah, I think that's a great way to go about it. I was lucky in the sense that I found a good company and a good team that is not hiring and not likely to be hiring for the future, that didn't require me to be an expert at Clojure. I did all of my interview coding in TypeScript, but I had a lot of functional programming things in my GitHub and on my resume, in the sense of like I gave a functional programming talk. I had that linked in probably my LinkedIn or something like that. You know, I led a Haskell study group and had that actually probably in my cover letter or something like that to companies that use functional programming. Just mentioned some of those things about my enthusiasm for functional programming, even though my Clojure skills were not, very high at that point. You're learning OCaml and find it very applicable. Yeah, absolutely. It's exactly how I felt about Haskell, which of course OCaml and Haskell are both MLs, both meta languages. Haskell predates OCaml, pretty sure. OCaml, I think, is 1996. I think Haskell is before that. I think it's earlier than that. But they have a lot of similar concepts and some things that are very, very different. But I think learning 1990, yeah, that's what I was thinking. It was early 90s. One of my favorite, like, I don't offer lots of like advice or hardline points at my old age. But I absolutely think that it is very beneficial to up level your skills, to learn a
an ML, you know, OCaml, Haskell. I don't know about standard ML. I've never used it, but learning an ML is going to make you think about problems very differently, force you to get used to a completely foreign syntax and all those kinds of things. Very different concepts. Having things that are auto-curried, all of those things make you think very differently about programs that you write. And then I also think learning a Lisp is a valuable use of time for similar reasons. It forces you to think about how to work with immutable data. It forces you to get used to a completely foreign syntax again. And I think it's very, very useful to have both of those things in your repertoire for learning everything. But, you know, I mean, that's not something I did before I was well fed and well paid. I also want to make that clear. So I'm definitely not saying, oh, you're trying to get into the industry, you should learn all of these things. That's not at all where that perspective comes from. Silicone Milk, how did you find the company you work for now? My favorite job search, which is very US centric, but there are some international opportunities as well. It used to be called angel.co/jobs. It's now called Wellfound. I haven't been on there in a while. I know the market's not as good as it was 5 years ago, but that has been where I've actually found. I've only worked 2 jobs in the last 10 years. Like, I mean, I was employed the whole time, but I don't switch jobs a lot. I found both of my jobs on that site. That's also because I have a preference for working at smaller companies. It is, you know, as AngelList is, more startup focused. So that's kind of where I come from there. I prefer smaller teams, smaller companies over big tech stuff. Cherry Heart, you're 22, classic Zoomer in chat. No, I'm just messing with you. So you're trying to learn all the things you can. Right now, learning OCaml and Common Lisp. Yeah, that's sweet. Yeah, I think that's great. I know a lot of people will learn a Lisp in uni, depending on where you go. I think that's great. But I think you'll have a lot of value from those things. You know, it's like if you need to get a job and you need to be well paid, then starting with OCaml and Lisp, maybe that's not the best route. You could probably do it. I'm just saying it's probably not the most common route. But if that's what you really want to do, fucking go for it. That's what I say. You know, I don't know. I did all sorts of things in my 20s. I didn't really get my first job till I was like my first programming job till I was like 28, so 27, something like that. Something around there. Exactly. JavaScript pays the bills. That's what I started with, and it made my life a lot better because hey, awesome. Congratulations, Sergio. That's so great. Yeah, that's awesome. Yeah, JavaScript I'm very thankful that JavaScript exists, as much as I hate the language, because it allowed me to get into programming in a very simple, accessible way, and it's so fucking ubiquitous that it was easy for me to get a job at the time, you know. I mean, it wasn't easy. It's not like I failed several interviews because of not having the technical not getting the technical interview right, but still learning JavaScript and then getting the opportunity that I did at my first full-time job was you know, I mean, it absolutely, you know, changed the way that I was able to live my life and the way that I'm able to work. I've always worked remotely. I have a family. I have a partner and a child, and I did. My kid is 14 now, so it's allowed me to be home and really like be a part of her life instead of being at some stupid office all the time. And I know that's not like relatable to everybody, and that might not be your choice, but you know, that was something that I really wanted, and I'm glad that I was able to do that. Very fortunate. But yeah, it's awesome. Good stuff. I mean, PHP is the other starting point for a lot of people. Again, JavaScript and PHP as programming languages, like they really, for the most part, suck, right? I know PHP has gotten a lot better. I have a lot less experience in PHP. I have had to write PHP professionally because of legacy apps at both of my jobs in the last 10 years. But they're still like the main things you can get a job in, and they're both relatively easy to learn. Yeah, I've seen some of the newfangled syntax, and it has some pretty insane stuff these days. Yeah, it's a lot different than the PHP that I used to mess around with at my last job, especially. And I mean, like this job too, because our PHP app is like literally 10 years old. So, you know, it's not using very, very modern syntax. Good times. Yeah, so our search was pretty simple. I think we went over that. And then our delete is our most complicated because of the way I decided to implement this, which is all within methods on these types, on these structs, instead of kind of in a normal recursive function. The way I do this is a little bit backwards. Basically, in order to have mutable access to the parent, I have to reach into the array. I have to reach into the tree on both branches and kind of keep track of that state in all these recursive functions, and that is a little bit. There's a layer of indirection there. Basically, it makes the code not as nice as it could be. But I just wanted to try to do it that way, mostly to learn more about how to mess around with like recursive methods and stuff like that in Rust. So that's it. From here, it's pretty simple. This is a match on the actual root. And then if I hate that I had highlight on somehow. I must have hit V at some point. And here is the delete from, which is a method on our node. And so self, in our first time going through this, self is going to actually be our root node, and then it's just going to choose a branch based on the value, right? And that's where you see that logarithmic action is that at each level of our tree, we get to split in two every single time. So that's partly why the binary search tree is efficient for what it is. So the complicated part of deleting is choosing what you're going to replace the node you're deleting with, because if it's at the top of the tree, you have to figure out how can we maintain the valid structure, the valid comparison structure of the tree when we delete. And essentially how we do that is we go down the left branch as one, and then we go down right as far as we can. So if we were deleting, this is a bad example because we don't have a lot of nodes. Let's see if we can insert a couple. 5, 9, sure. We'll just put a couple 9s in. It's not ideal, but it'll work. Actually, you know what? Let's do this. It'll make the example better. Let's go ahead and go with a 7. And then we will go with an 8 And we'll go with a 9. And we'll put in a 6. Okay, cool. So what we would see if we wanted to delete our node at the top here is that it's going to go down left, and then it's going to go down right as far as it can. So let's go ahead and delete our root node. And no matter what level you are deleting of the tree, that's always going to be right. So for instance, 900, if we deleted 900, it just gets replaced with 800. That seems kind of obvious because it doesn't have anything else on the right branch. Let's see if there's any other good examples that I can think of. Like if you delete that 7, for instance, it's just going to get replaced with the 6. That's a better example since 7 had a right branch. Pretty cool. So that's how delete works. So you have to figure out how to both swap those values as well as swap out the node that you just swapped out. So there's kind of like a double swap action that can occur, and you have to figure out how to do all that. And so delete from mostly handles finding that node that we're deleting and then recurring down the tree until we find that value. Once we find the node that we're actually deleting, we actually call the swap node method, and the swap node method is what does most of that work as far as replacing both finding the node that we want to swap with as well as replacing that swap node with one of its children as well in order to maintain the structure of the tree. So I didn't explain that perfectly, but that's okay. So that's our binary tree and binary search tree. A little bit different. Binary search tree is a binary tree, but there are other binary trees. So that's that. Not bad. Yeah, Asha, Dev, cool. Yeah, good luck with that. It's awesome. Get it done. Get it done. Don't let consuming content keep you from getting done what you need to do. That's only true for Asha Dev. Everybody else should stay and consume content. Yeah. If you want to check out the code, there's the GitHub, and let's see. Oh yeah, and for those who, oh wait, I almost used the wrong command. There we go. I already plugged YouTube, but it's there. That's the Twitter thing. So if you're on that sort of platform and you want mostly bad takes and mostly bad dad jokes about programming, and I just, like post when I'm streaming and stuff like that, then you can follow me if you want to. Okay, so we went over a binary search tree. What should we actually do next with our binary search tree? I'm trying to tell myself to add markers, and I don't know. I've been doing really bad. Okay, what's next with BST? Nice. Something went wrong. Try running that quick action again later. Oh, gosh. Okay. Can we do it in chat, like here? Like Prime does it? What's next with BST? Nope. Classic. Bummer. Okay. That's annoying. Okay. So what else might we want on a binary search tree besides insert, removal, and search? I remember what else we want. Okay, so a cool part of this that you probably have already figured out is that a binary search tree is sorted, right? It even says that 4 lines up from where my cursor is right now. So one of the nice things that you can do, depending on what you want to do with your data from the binary search tree, like as an example, let's say you were done searching, or you want to take a snapshot of the current state of the tree or something along those lines. You might want to, both as an input and an output, have something like a vec. So if we say vec input and output, that could be cool. We can't use the Rust slice type because we don't have contiguous memory for a binary search tree. But once you can output a vec, then you could do that. So what we could actually implement is from vec of t, and we could implement, let me think, how do we want to implement the output? I'm spacing right now. I mean, I know there's an n2 vec. In general, they say implement from, and then n2 is already done. But I don't think, I'm pretty sure that I cannot implement from BST for vec, right? It's not like I can implement a trait for a type that is in the standard library and then it just work. So I think what I would have to do is actually, in that case, implement into vec_t. Okay. I think that's a great next step. Let's do some research on the n2 portion. I was just playing with some XML. I was testing myself to see if I could write a really simple XML parser without really thinking about it this morning. It went okay. I did an enclosure. I didn't like, hey Gio, how's it going? How have you been? Let's see. Do you guys want to see my closure XML parser that's like totally not complete and doesn't support lists yet? Oh, Slurp Waffle. I'm sorry, I missed your follow. Thanks so much for the follow. Let's see. I just put it somewhere. You don't need lists. Who needs lists in XML? Yeah. There you go. There's my XML parser, assuming that all you have are actual, what do they call them in XML? Like nodes or something? I don't know. And you don't have lists. So it doesn't actually support the actual string that I have above as an example. But that was my next step. I haven't actually tested it out to see if it works. It might not even work. That was just like, I was a little bored. I usually work on Sundays, and I finished like what I needed to do pretty early, so I just decided to do this. Yeah, you know, there's a little closure for you guys. All right. Lists are all you need. That's not inaccurate. not inaccurate. You can, you feel closed? What does that mean? You feel, oh, because of closure. I get it. It's pretty good. It's pretty good. Who knows? Who knows what that means? Yeah, usually when I have to say who knows, I don't know what I'm talking about. It's usually I made 5 jumps in my head, and there's no way I'm gonna like backtrack and explain those 5 jumps to everyone. Trust the repo. Yeah. Oh yeah, did I ever finish my thought that I'm thinking about doing a Clojure SDK for CM Griffing for his Vexilla, like streaming with him to do that? Just in case anybody's interested in that. I was just wondering if anybody thought, if people had thoughts. You don't see a lot of Lisp on Twitch. This is true. So that's kind of, yeah. So CM Griffing, who's like a much bigger streamer than I am on Twitch, he has a project called Vexilla, which is a feature flagging product that he's working on. And like DM Griffing, for instance, DM Griffing, oh my god, DM Mulroy, oh Jesus, is developing an OCaml SDK for Vexilla on stream, and so somebody was like, oh, you know, Meta, you should do a Clojure one, and Chris, CM Griffin, was like, yeah, you really should. And I don't know, I've been thinking about it, that's all. So it'd just basically be me on his stream writing the Clojure SDK. So yeah, exactly. Yeah, they did a couple of collab streams. Yeah, so it'd be similar to that, like the same collab, except of course we'd be writing Clojure. I don't know, I'm thinking about doing that. I don't know when I can, because Griff's stream schedule and my stream schedule don't have very good overlap. So I'm not exactly sure when I can work that out, but I'll have to talk to him more about it. Anyway, it's a thought. Okay, what were we doing? Oh yeah, we were going to see, like, it's obvious to me that I shouldn't be able to do this, but what the heck happened over here? Recursive derust? Like, what is this? I only use English in GPT. Why is it giving me recursive derust? Let's see, what is happening over here? This is literally just recursion. Can I have a recursive method in Rust? Yeah, okay. Recursive derust. Nice. What is that? Like, I don't even know what language that is. What? I mean, I'm sure it's like what's D? What would that be from? I don't know. Interesting. Fun. You got that clip. All right. Oh, that's funny. That's good stuff. The DM Griffing. Classic. I'll have to put that in Dylan's Discord. That's really funny. Nice one, Teeny. Nice one. Yeah. Me just like completely fucking up everything, especially people's names. Oh, that's funny. Okay. What were we doing? Oh, yeah. We were going to just... Oh, right. We're going to ask about implementing... Can I impl a from vec? No, that's not what I meant. Okay. With my own custom struct, my struct, can I implement a from my struct t for vec t in Rust? I'm pretty sure that it's lying, but we'll see what happens. In Rust, you can implement the from trait for your custom struct, but there are some constraints on how you can do it. Yeah, that's what I was thinking, Geo. Yeah. However, in your case, you want to convert your custom struct. I just wanted to make sure, you know, because it's very, well, it's not like me, actually, probably, to not make sure. You guys would probably know better than I do. I just want to know absolutely for sure. Like in my head, I was like, no, that doesn't work based on other things I've read, but I always just have to double check. This is not directly possible with the blanket implementation of from, but you can do create a custom, yeah. Yeah. Yeah, so that's not, it should have just said no. No, you can't. Right. Any trait on a struct in your crate. Let's see. I don't have an example in this file. Let's go to our ring buffer. We got lots of traits on a ring buffer. So just as an example, like when you impl a trait, you have your right hand side of this trait is the way I think of it, and your left hand side. And basically what Geo is saying is whatever is on your right hand side has to be something like in your crate. That's the way I would think about it. I think that's like a really simple way of putting it. Whatever you're doing the implementation for has to be your own type, your own struct, etc. So yeah, that was my assumption. Okay, well, let's see. What time is it? Yeah, I have a little bit of time. Let's get started on a from, and then we'll see how far we get from that into. In some ways, I feel like if I'm going to do into, I might as well just do an iterator because the logic is going to be very, very simple. I thought it only cannot be both from someone else. Huh. Peanut butter jelly time. Man, PBJs they're so good. So good. Some people don't like PBJs. I don't know how that's possible. I thought it only cannot be both from someone else. Well, maybe I didn't explain it well. I guess what I'm saying is I cannot say impl t from binary search tree t for vec t. Like I can't do that, right? Is that why it's being weird? Oh yeah. Classic. Okay. That's why it was red. Thanks. And then thanks LSP, even though you didn't indent? What? Okay. Okay, well, let's just try this. Let's just say... yeah, it won't compile. Let's just play with it, right? Vec 1, 2, 3. Wait, no, that won't work. Vec. Here we go. This is what we'll do. Impl t default. And then we'll say vec t default. Okay. What in the world? Okay. If this is intentional, prefix it with an underscore. What? Vec allows vecs to be defined with the okay, creates a vec containing the arguments, yeah. There's no way it's gonna let me do this, right? Okay, we're coming back to this one. Can I actually do this? It does compile, Geo, but what I'm wondering, this is my thought. I could be wrong, but my thought is, ooh, that was nice. You see my little documentation under here? These are my little points that I put above because I used a doc thing. How about it? Oh no. Okay. Aw. So cute. Okay. Can you use it in a test? Yeah, we can try. All right. Well, let's just do it here so we can easily see it. Yeah, I mean, that shouldn't happen, right? Even though it's unused. Okay. So what am I going to do? I'm going to say create a BST. Sure. Let BST equals binary search tree. I size, sure. New. Okay. Let v equals. I always forget how this actually works. Let's see. Let v equals vac. I know usually you would do this implicitly, but I'm just trying to remember how this works. It's just a static method, right? So I could just say vec isize. Oh, well, right. Can't I actually do it this way? Let me figure this out. Don't tell me. I'm playing, okay? If I say vec isize bst, will it just like work? What is this about? Okay. Mismatch types. Okay, that's fine. That I think I'm thinking maybe I don't have to put the type parameter on both sides, and that's what I'm thinking. I don't know. Vec isize. Oh yeah, I have to do this. Similar to what I have there from BST. Okay. Assert eq vec t default. I don't need isize. You're probably right. V. Yeah. Oh yeah, I'm being dumb. I have to put I put T instead of isize. Implied by BST, yeah. Okay. So that builds. Okay. And then let's take Geo's suggestion. Do that the hard way. Yeah, sweet. That's nice. Very nice. Okay. And okay, it builds. Then it tests. TIL. TIL. Now, what I'm wondering, Geo, I have two questions. One is, I could see that what am I trying to say? Oh, this is what we should do. Here, let's go into our lib, right? And let's do this. In lib, we are going to say does impl from U32 fail to compile? We can try it. So let's say what we have, our binary search tree. So we say let Peter Simonson, I'm sorry, I don't think I ever said thank you for the follow 15 minutes ago. If you're still here, thanks. I appreciate it. A very nice Nordic name you have. Very nice Scandinavian name. All right. Let's see. Hold on, my brain has to get over Scandinavian Norse stuff. I'm gonna get there. I'm not gonna recount my family history right now. We're just gonna make this work. Okay, I think I did it. Okay, let BSD equals. I guess since I didn't I actually don't know how this works when it's supered. How do I get to binary search tree? Do I automatically have it in the scope? Probably not. Nope. All right, let BST equals binary search tree. Binary search tree. No, Vec's not custom. Oh. Damn it, you're absolutely right. I bet you're right. Oh my gosh. Here, I thought I was breaking everybody, but no, but I'm not. I don't know. Because, okay, let's figure that out first. Okay. Let's figure it out first. If I just do this, then let's just do one more thing to make sure. I do have a vec defined here. You're absolutely right. It would be really funny if that's what it was. The only thing that's weird about that is that my the vec macro shouldn't actually work for this vec, and I don't have it used in that other place at all. But I mean, I don't know. Here, let's do this. We'll do a global replace of vec with my vec. And then write that, go here, go here, run tests. Yeah, still works. It's the actual normal vec, and we can also make sure the LSP thinks it is. Whoops, wrong one. Let's close that. Yeah, alec vec, vec. But my thought, Geo, is that maybe I can use it in this library, but I wonder if even if I imported the library, like if somebody imported my library, would they actually be able to use it? I don't know. I think that might be the limitations that GPT is talking about. But let's just keep playing with this because it's fun to know about. All trait impls are public. Oh, you're saying they would be able to use it? They'd be able to use my trait implementation? It just seems weird. I mean, it's a nice feature. But the part that would feel weird to me in some ways, no, I guess that's fine. Because it's still, like, I still own the first type parameter, so it shouldn't cause any undefined behavior for anybody else. That's pretty weird, though. Pretty weird. Okay. So does this work? Yeah, it seems to work. I know it's verbose. Let's just keep with our iSize example. Okay, this looks fine. Let v equals vec from BST. This looks fine. And assert impl t sum trait for t works. Yeah, I mean, that does make some sense that you can have like a fully generic trait. But yeah, for some reason I really thought Rust didn't let you do this. But obviously it does, and we were all mistaken. Which is pretty funny. iSize default. Pretty darn funny. Okay. Yeah, that is not a function. You are right. Yeah, right. Hold on. Let me go relearn everything I thought I knew about traits. Oh, that is funny. This is why I like to double check things. We can't implement external traits on... Wait, no. For example, we can't implement the display trait on vec_t within our own and aren't, because display and vec are both defined and aren't local to our aggregator trait. This rule ensures that others people code can't break your code and vice versa. Okay. But here's the difference then. Okay. So, yeah. I remember reading that in the book. I did go back and read sections of the book that I thought I would need to. From is defined in the standard library, but it's only defined for certain types, right? And so here's how I'm okay, let's see. Because display and vec_t are both defined in the okay, no, that doesn't make sense. I think they're wrong in how they worded that. Now, if I tried to implement display for vec_t, it wouldn't work. But if I implement display I wish I could change it so that my auto switch only happens if I click on the actual window that I cared about in the browser instead of just clicking chat, but oh well. If I implement, yeah, so I can't implement display for vect because the display trait is actually implemented for vect within the standard library. So I think they just didn't say that very well. But the from trait, while from as a trait is defined in the standard library, from binary search tree T is not defined in the standard library, and thus it is acceptable for me to implement it for vect. Yeah, that's got to be it. From my struct, count as defined in your own crate. That's why you asked about from U32. Yeah, so if we did, let's just do a new block. Impl U32 from U32 for vec t. Let's just let the LSP fill that out. And then we say vec U32 U32. Yeah, I didn't need that. I know that. I know that now. I'm just so used to generics. I'm so used to defining generic parameters that when I have an actual concrete type, I forget. Okay, here we go. This is probably going to give us what we were expecting. Let's see. Cargo build. Oh my gosh, nope. So far I'm just being dumb. U32. Let the man cook, Geo. All right, we're getting there. We'll get there. No, I'm just kidding. It's fine. Impl doesn't use only type. See, it's still, I still find that this is bad language. No, I'm just kidding, Zero. You're fine. Typos are totally fine. I was just messing with you. You know, if you're like backseating my entire implementation of something, then I would be annoyed. Right? But like telling me I made a typo, it's like, yeah, it's probably that's worth doing. Okay. Yeah, exactly. Type a new line. Oh no, you should be using this function. Actually, you did this part wrong over here. Oh, why aren't you just doing it this way? Dude, I'm trying, all right? I'm thinking through this, all right? Yeah. So this is, so this is where let's make this bigger. I think this is bad language. This is bad language these people are using. By saying impl doesn't use only types from inside the current crate, I don't think that that's actually correct as far as what they actually mean here. Because I mean, I don't know how I would make this error message better, but both the book and this error message would seem to both imply what we thought wasn't possible. And in fact, it is possible. And now we know. Well, I think that was a useful distraction. So for any sum trait t, you need to have t inside your crate to impl. I think that is correct, yes. I think because the trait has a generic parameter, I think that is correct. Ignoring if you even whether or not you created some trait. Now the thing is, the question that I still have that I don't have an actual answer to is, for instance, say the standard library did not actually implement display for vec. Could we then implement display for vec? That's what I'm not sure of. Does that rule only apply to a generic type, or does it apply? Yeah, I wouldn't think so either, Geo, but our reality has been shaken. Yeah, I know, right? Yeah, it's a little unclear. So, yeah. Well, that's cool. It will make the syntax pretty nice and more useful. So I was thinking about starting one of these implementations, but okay. So let's do this. Let's just get kind of our boilerplate out of the way, and realistically, I'll have to come back to this. I think tomorrow. Pretty sure tomorrow's a good stream day. Okay. To do. I don't know. Maybe actually return the values in the BST. Okay. That's a good to do. It's absolutely how I would write that to do at work. No doubt. Macro as return? Yeah. A macro as a return type is kind of funny, huh? Okay. So then the other thing we want to do is impl t from vec t. Oh my god. If I knew how to type, we'd be good. For binary search tree t it will panic if you try to use from before you implement it. What do you mean? I'm not sure what you mean. Which from? Function from value vec t. Oh, right, the to-do macro. Oh, that's what you meant by to-do macro as return. Look at you guys. I haven't actually used that very much. I know it's like very idiomatic, right? Like it's just what you do. To do. Okay. Good. You've been using it too. It's idiomatic Rust though, so it's fine, right? If we define to-dos as idiomatic, then suddenly we're idiomatic even if we don't write the code to make things work. Okay. You have like 20 to 30. It's hilarious. Let's see. 2 vec of t. No, it's just self, right? I was thinking I had to do it the opposite of what was above. To do. This actually shouldn't be all that hard. I don't know. Let's see. So from value means we're actually consuming the value. I don't know. This is actually not, it's not that hard, right? Like as in, can't I just say value dot iter dot, of course that doesn't actually consume, but it will just drop it after. There's probably a nicer way of doing it, but it's fine. It suddenly compiles. And as we all know, we need like a, oh right, n00 iter, that's the one that consumes it, right? It consumes the vec. Yeah, good call. As we all know, if it compiles, it works. I love that. I love that. Rust code, bug free. Bug free Rust code. Here on stream, live on Twitch. Bug free Rust code, TM. Okay, values dot n00 iter dot. What do we want to do? Like a for each? I mean, I could do a for loop. Or can I just do a map? Or does that not give me what I want? Map v. Okay, no, it gives me an ont. That's what I wanted. And then, oh yeah, I gotta, just maybe. Let mute bst equals binary. Oh my gosh. Look at that typo. RT. Binary search tree. T new and bst dot insert b and bst. Okay. What you hate about me now? I did it again. Did I do the thing? Oh no, I just didn't declare partial eq. I just assumed that I did it in the wrong order. I'm not looking at chat because I'm cooking right now. That makes sense that I have to declare partial eq there. What don't you like now? The function or associated item new exists for struct binary search tree 2, but its trait bounds were not satisfied. Oh, is it because I still have debug? It might be. Let's see. What else do I have? Oh no, it's partial or not partial eq. I'm being dumb. I just forgot what trait I needed. Partial ord and debug. Okay, I don't actually need debug anymore. I mean, it's fine. Sure, we'll just keep debug on there. We'll probably regret if we take it off, right? I just need to actually import debug because I never did. Let's see. Binary search tree. Now I'm guessing what I need in order to keep that there, I'm probably going to need this up here. Yeah, I could do a fold. That would be nice. Use stud format debug. Okay. Debug. Oh, let's see. No, that was a dumb way of doing it. I always do this. Okay. Now we just need to actually make this partial board. Nice. Let's see what else we need. First try, fold instead of map. Yeah, fold is a good idea. I already read that and I already forgot. Fold can be nice here. Let me think what I want. Value.intoiter.map v_bst da. What is the actual error so I can understand what I did wrong? Unused map that must be used. Iterators are lazy and do nothing unless consumed. Oh, okay. Then fold is nicer, right? Because it also expresses it better, right? Because I don't actually want to map. Yeah, fair point. So let's do a fold. So a fold should give me a V as my first. No, actually it should be a V and a T. I always forget which order it is. There's always options. Yeah, I know. But if I can make it a one-liner, I really like one-liners. Why am I forgetting how fold works? Let's read the effing docs. RTFM. Self init bf function mute b self item. Okay, so T comes first and then V. Okay. Yeah, I did that a boomer way for sure. Init val func? Yeah. Oh, I forgot the init. Oh my god. It even says it right there on my freaking LSP. Binary search tree. Oh, because insert doesn't return. All right, this is too annoying. For V. We're gonna change this into, yeah, I could return BST in my insert. But then I'd have to change my API and I just don't feel like it right now. BST.insert V. Yeah, I know. I changed that because value is, whoops. Not good for me. First try. All right. Let's just make this that so it stops warning me. Yeah, I know, right? Hilarious. Classic me. It's funny. I really tried not to use imperative structures in Rust when I first started. Oh, you're right. Now, does it call into iter or does it call iter? I never was sure about that. It does call it into iter? Okay. We can make it nice. Unless it's a ref, that makes sense. Oh, I guess that makes sense because already, right, by doing invec, it's pretty obvious that I'm moving it right in the way that we would think about it, where if I do andvec, then it does this. Yeah, that makes sense. Smart Rust. Look at that smart Rust. Knowing what you want because it knows what you gave it. Impressive. Wow, that shock wasn't so bad. Can you guys even hear that? Let's see. a little bit. It's not bad. Sorry, I did it like 5 times. Cool. Okay, let's write a quick test. I mean, let's say from vecworks. I know I was using this for my other thing. Let's just restart. It'll make it easier on my brain than trying to edit. So if we have a vec equals vec 1, 2, 3, really good example. It's gonna be a totally terrible tree. Okay, let's maybe not pass it something sorted. Oh goodness. Okay. 3, 10, and 0. Sure. When it's a ref, you can get you can and v to get t in loop. Ah, yeah. Okay. What do you mean not a fan of, like me? I'm not a fan of mutability. I mean, you mean because I don't know what you mean, Teeny. It's probably a good comment. I'm not a fan. The change of the old code. Oh yeah. Exactly. Hey, Scottish Trio. Yeah, we finished Elite today. Yay! So now we're just implementing some treats. Oh, I've been streaming for too long. We're implementing some traits. Halloween on the mind. All right. Treats. All right. Yeah. I absolutely. Yeah. Treats are traits, and traits are treats. Good times. What are we doing? I already forgot. Right, we should get a binary tree from this. So now we're gonna say let bst equals binary search, not quite, binary search tree from vec. Hey, look at that. That's pretty darn cool. Assert. No, it's just assert, right? What do I want to say? bst.search 10. And we'll just check for all our values because why not? Are you serious? Did I really get a failure? That would be disappointing. Does this not return a Boolean? Did I have search not return a Boolean? I don't remember now. I thought I just returned a Boolean. I could just look at my other tests. No, I did it. I did do that. Yeah, it returns a bool. Okay, let's print it. You haven't touched any of your programs in days? Nah. All right. I gotta leave soon, even if this. Oh shit! I forgot. Wrong test. From vec works. I gotta leave soon, even if this doesn't work. Sadly. What test result? Okay. What failed then? What failed? Oh, my it works test failed. Oh my god. I'm just being stupid. Oh, right, because I did a to-do. Yeah, because instead of leaving that geoset, I should do a to-do macro. And now I have a test failure geo. Just kidding. All right. Okay. Good times. Either way, I wanted to print it anyway, so to make sure that our structure looks right. So we should have inserted 3 at our root. Yay. And then... yeah. I do know test TDD, but I don't do it. 0's on the left, 10's on the right. Nice. Yeah. Pretty freaking cool. No doubt. I like that. It's really nice. The from BST for Vec is going to be a little bit more complicated because we actually haven't done any of our like searching. But like I think what makes the most sense is we implement like into iter, and then we just get the from that. You should add refs to nodes. Oh, I know. It's bad. I'm assuming I know what you mean. There's the main things that are bad about what I do. Yeah, I think we are. Like, I got you. Like, insert is fine. What did I do badly that I've done so many bad things, Geo. Just done so many bad things. Father, forgive me. Just kidding. Okay. Yeah. I mean, there's definitely some things that are like non-idiomatic here, mostly around. I'd say mostly around like not treating things referentially like I should. But yeah. Traits and treats. But yeah, I don't know. I'm pretty happy. I don't know what I'm doing. I think I'm tired. I think I'm ready. I'm ready to move on. Yeah. I was kind of like fading for a second there. Yeah, this is awesome. I'm happy. We basically got this going. Doesn't impl from T F imply impl into F for T? Yes. You're right. It does. Wait a second. Implementing from T for F implies into F for T. You're right. How would that actually work in this case, though? Wait. Impl from vec for BST. Oh, you're right. So I should be able to do an N2. Yeah. So if I implement from BST for vec, then that means I should be able to do N2 vec for BST. That's what you're saying, right? Yeah. Yeah, you're right. It does do that. Let me think about this for a second. So that means that by implementing from vec for BST, we already have vec.into BST. Yeah, right. Yeah, that's why you don't have to do into. And they say, as long as you do from, into is already there. I am obviously tired because my brain like had such a hard time putting it together, and I literally just like read that like 2 days ago or so, like for the 10th time, and my brain was still having a hard time putting it together. Oh my god, pretty funny. Awesome. Well, this was a lot of fun. Thanks for hanging out, people from the raid and people not from the raid, and it was good. I think we're going to yeah, we'll do an iterator on our binary search tree next. Stdlib impl of n2t. It's one line. It's funny. I'll have to look at it. Remind me next time. We'll look at it. I'm tired. I need to stop. Yeah, next time we'll do this. We'll do an iterator. Let's see. Should we just put this here? Impl t iterator. Of course, we're going to have our type. Yeah, no. I'm just going to do this. Whoops. I was already in insert mode and hit I. To do. Okay. We have our iterator to do. We'll do an iterator. We'll do into iterator. We'll use into iterator. And yeah, I know it's not. It's just force a habit. So we'll do iterator. We'll do into iterator for BST iterator struct. Time to go do something that, whoops, not what I meant to do. T, there. Yeah. We'll have a good time. Anybody want me to raid anybody specific? I don't see anybody I usually raid. Hero's going. We could raid Hero. Let's see if we have somebody else. Xenome. Hey, thanks, Deanie. I appreciate it. Always appreciate you being here. I'm going to stop the recording here for the YouTube folks. Catch you next time. Better like and subscribe this. How about that? I just threatened people. Who'd you say? Xenome. I don't know this person. Xenome. No, that doesn't work. I'm the only one doing Rust here. Because of my auto switch, I really should put you over here. Oh dear, what is on my homepage? Who even knows? Xenome, huh? Okay, let's do this because I'm a boomer. We're gonna go to hero, and then we'll do this. Xenome. Oh, dude is gaming. Yeah, let's do hero. I've never rated hero before, so why not? Thanks so much for hanging out in the chats. BST basic is done, and it's a chat RPG game. Oh, it's very cool. I'll have to check it out sometime, Gio. And yeah, we'll catch you guys later on the flip side, as they used to say when I was a kid. When I was a very cool teenager. Extremely cool guy. All right, see you guys.